Before the discovery of oil in 1950s, even before the establishment of United Arab Emirates in 1971, people worked on simple jobs for a living like fishing, farming and pasturing. Due to different topography of mountains and sea as well as geographic location, houses were different depending on available local materials. In the desert, Bedouin used to live in tents called batt made from animals' hair and skin. They were easily installed and uninstalled as they move around a lot searching for water and plants to feed their animals that they raise. In winter they add layers to the tents to make it warmer, while in summer they allow the tent to be breezy with less layers, allowing for air exchange and flow. On the other hand, people who lived near the mountains built their homes from the stones of the mountain. While people who lived near the oasis who owns farms and work in agriculture, their houses were made from palm fronds and called batt al-arish. Near the sea, people worked in fishing and pearl diving as a main source of living. Their houses were made from mud and coral stones gathered from the sea with simple building techniques. In the 60s, with trading flourishing with India and Iran and other countries, they started to exchange and import materials. Their houses started to be bigger with interior courtyard and more rooms. Dubai al-Bastakia area shows a more advanced houses with 2-story and made from mortar, sea stones, mud and clay bricks. They were well insulated due to layering techniques. In addition to that, wind tower or catcher called locally bargeel provides natural way of ventilation. Naturally the warm air flows upward, making the rooms underneath it cooler without air conditioning. Besides, they used to illuminate their house with oil and gas lamps. In current days in UAE, there is unlikely to have any building without electricity. Electricity changed the lifestyle of not only people but buildings as well. As Dubai located in hot area, air conditioning system is a must, especially in summer season. Also, we use artificial lighting to illuminate the buildings at night. Current houses are made mostly from concrete, steel, glass and other materials. If not well insulated, it can enlarge the rate of energy consumption by the need of more cooling to make the indoor more comfortable for the occupants. Current houses are not fully sustainable. As a solution, we can learn from the past and apply sustainability energy enhancement strategies. Taking a villa in Mushrif village as a study case, where annual energy consumption rates is collected from Dubai Water and Electricity Authority and analyzed. And then apply energy improvement strategies from base case to improved case scenario gradually, like thermal insulation, shading, artificial lighting and finally generating electricity by solar PV panels. The method of assessment will be by using computer software simulation methodology integrated environmental solution. The aim is to study the progress of sustainable housing architecture through timeline frame, focusing on houses in UAE from the past and link sustainable feature to present houses to enhance the performance of energy efficiency and residents' comfort. This is achieved by testing energy efficiency strategies, taking a villa in UAE located in Dubai Mushrif village as a case study. The villa located in Mushrif village in Murdif across Mushrif Park and in front of Al Kawaniya Street. It is 10 minutes away from Dubai International Airport and located between two main roads, Mohammed bin Zayed Road and Emirates Road. The annual electricity and water consumption rates were obtained from Dubai Electricity and Water Authority. The annual consumption rate from 2019 January to December is 43,062 kW per hour. It is noticed that the month of August is the highest electricity. By simulation, total of the energy consumption rate is 42,849 kW per hour. The difference between the actual case and the simulated case is 0.5%. The sustainable strategies options selected are for thermal insulation. Options are glassfiber, batt and polyurethane foam. As for shading, options are horizontal, vertical and overhang with side fin for artificial lighting, incandescent, CFL, and LED. The first strategy, thermal insulation. Additional advantages of thermal insulation along with saving energy is protection from humidity. The first thermal insulation option, which is spray applied glass fiber, the total energy consumption is 42,849 kilowatt per hour, while the second option is, which is glass fiber batt, the energy consumption is 40,580 kilowatt per hour. Third option, which is polyurethane foam reduced, the total energy is 36,820 kilowatt per hour.
Second strategy is external shading for windows. The first option is solid horizontal overhang placed above the external windows to provide shading. The total energy is found to be 35,790 kilowatt per hour for this type of shading. Moving to the second shading option, which is vertical louvers placed on the windows, the total energy is found to be reduced to 35,410 kilowatt per hour. The third option is overhang with fence. The total energy is found to be a bit higher than the second option, which is 35,460 kilowatt per hour. It was found out that best among the shading options is the vertical louvers.
The third strategy, artificial lighting. From the many options of lighting, LED light bulbs are the best in energy saving. Last method is applying renewable energy generation solar panels system to Dubai's blessed with sunshine. The annual sunshine hours in Dubai ranges between 8.2 to 11.4 hours. The solar energy can be utilized as a clean renewable energy to reduce the dependency on non-renewable energy sources. Photovoltaic solar panels can be installed in the rooftop to generate electricity to the villa. By using Shams Dubai project regulation, a standard size 100 cm by 165 cm was selected. As a result, the east side orientation was the best option. Comparing to green energy rating system in Dubai, the villa achieved golden al-Sayafat rate. To summarize, the best options are polyurethane foam for insulation, vertical louvers for shading, LED lights, and east side orientated solar panels. With all the technologies, current homes are able to be more sustainable with introducing smart technologies like three-dimensional house printing and home automation. But in the future, houses are not only going to be sustainable but also smart with the help of the Internet of Things and artificial intelligence.